We're recording.
Oh, right. So this is a video demonstration of our Project 3, which is a multimeter, digital multimeter. You can see here we have our MSP board hooked up to the oscilloscope and our terminal window here, and also to this nice, lovely comparator on our breadboard, which takes any input signal and makes it an easy-to-read square wave from rail to rail. Over here we have first set up a DC voltage at 1 volt, and if you look over here at the terminal, you can see it's reading as 1 volt, and you can see it has 1 volt max min because there's going to be some noise, and we don't have actually a frequency on this because it's DC and there is no frequency.
Alright.
We're going to show you one more DC voltage, probably around 2, I would say. So yeah, there's 2, and you can see it updated to 2, and we're still within acceptable noise range for the max and min. Now we're going to switch over from our DC waveforms over to a sine wave, or actually a sine wave with 3 volt peak to peak at 1.5 offset. So we 1.5, and we'll knock this up to 1 volt peak to peak. You can see our comparator has done the work in making a square wave for us.
We're also going to put this at 500 hertz.
Oh, thank you. I can read.
There we go. 500 hertz. Now let's compare. So
you can see our frequency is now 500 hertz. Our max and min are 2 and 1, which is what we expect from a 1.5 DC offset, and our RMS value looks about correct for this waveform.
Alright, let's move on.
We're also going to test this at different offsets, so we'll increase it here to 2.5, which should give us a 2 to 3 peak to peak, and this is going to be at 1 kilohertz. Nice and fast. Alright, now we'll go back here and we'll see we're getting 1000 kilohertz, give or take 1 hertz there, every little bit there. We're still 1 volt peak to peak, and our max and min are within acceptable noise range, and you can see our DC offsets at 2.5 now. RMS where it should be around 2, or a little above 2.
Okay.
Now we're going to go down to the other extreme, and we're going to do that at also 1 kilohertz. So let's move the offset. And you can see while I'm doing this that the comparator actually is not changing, other than in terms of frequency. It stays at its rail to rail, despite on where this goes. That's because it has a reference point of the DC offset, so it always has a reference point to the sine wave. So long to get here. Okay, so now we're 0 to 1, which is still 1 volt peak to peak, and you can see that we're within acceptable noise range there. And you can see the DC offset's at 0.5 volt, which is perfect. Our RMS is quite low, and we expect it to be low for this kind of signal. Frequency still holding where it should be. Now we'll switch over to a triangle wave at 1.5 offset. And 3 volt peak to peak. So this goes from 0 to 3, which is our full range here. And you can see the frequency still holding. And max and min are within acceptable ranges. Now that they've updated there, I was worried for a second. And our DC offset is at 1.5, and the RMS is holding where it should. I'm going to lower the frequency on this. Oh, I remember to switch over to frequency. And we're going to bring this down all the way down to 50. Maybe. Watch my frequency. There it is.
All right.
And
Check it out.
This box here,
you can see there.
facing the left.
And that's 50.
Yeah, within 1 hertz noise ratio, I'm going to say. Within range, acceptable meters. And everything else is holding as it was before, and we're all good. We'll switch over to a square wave right here. And you can see that doesn't break anything on the screen as it stands. Everything still works here. Our one issue we did have with this project, though, is it will probably freak out with frequency as we go lower than 46. Yeah. So as we go down to 10 here, it does not like that, and for some reason thinks it's 76 hertz. But if we go up to 1 kilohertz with the square wave, it will indeed be happy with that.
Nice.
I believe that's all we needed to show for this project.
Okay.
So thanks for watching.
And then we have our vertical brackets, our horizontal brackets here, as requested. And our special sauce for this project is displaying the max and the min voltage values.
From the
Right
5-volt
there.
battery, you can go to the 12-volt battery.
All right. That's it.